Okay, Humayt is off. Humayt, you were not present in the last lecture, I guess, right?
Yes, sir. I had extra classes. I'm reaching home
Uh,
by 5:30, so I was tired, so I slept.
oh, okay. What extra class? School.
Sir, I
School
can't hear
extra
you.
class. I'm asking, was it school extra class?
Yeah, at school.
Achha. Okay, okay. Fine. So in the last lecture, we have already seen that how to identify a plus M group and a minus M group. Okay. Now, please write a few points as note. The first point is we have seen the mesomeric, we have seen the resonance, the effect of resonance in different type of with different type of groups, NS3, so NS2, OH, OCS3, CHO. In all of these cases, we have that effect of any group in the meta position. If you look at the resonating structures, then either you are getting a delta positive charge or you are getting a delta negative charge, but only on the ortho and para positions. There is no effect of mesomeric effect on the meta position. So please write this point. Mesomeric effect does not have any influence on the meta position. Meta position of what? Of benzene ring. Okay, right. Plus M group increases electron density of benzene ring at ortho and para position, and minus M group decreases the electron density of benzene ring and para position. Okay, so there can be questions regarding the stability of different types of reactive intermediates, including the mesomeric effect, which will have the application of mesomeric effect. For example, compare the stability of following. So here we are having CH2 free radical. Now, obviously, we should know that carbon free radical, it is electron deficient thing. Okay, so we have carbon free radical, and in the first carbon free radical, there is no group attached to it. In the second case, we have OH group attached. In the third case, we have NO2 in the ortho position, and then we have OH in the meta position. Okay. Now they're asking you guys to compare the stability. So first of all, see, we have A structure, this is my B structure, this is C structure, and this is D structure. Now you should understand the first point is that the carbon free radical is electron deficient. Okay? So it needs electron. Correct? Yes or no, please tell me, guys.
Yes, sir.
Right? Okay. If I look at the CH2 free radical, there is no group attached here. So इसको आप क्या लिखिएगा? इसको there is no group attached. I mean there is no position also. So I will write that it is neutral. मतलब इसका कोई इफेक्ट नहीं है यहाँ पे, है ना? It is the zero part. और I will say that it is zero. जीरो है, न्यूट्रल, मतलब इसको अपने हिसाब से आप समझ सकते हैं, बस समझने के लिए दे आर नॉट गोइंग टू आस्क क्योंकि न्यूट्रल है या जीरो से रखे हैं. यू हैव टू अंडरस्टैंड इट ऑन योरसेल्फ. नाउ व्हाट इज द इफेक्ट ऑफ OH? टेल मी. इट इज प्लस m और माइनस m. इट इज प्लस m और माइनस m. OH है ना. देखिए ध्यान से देखिएगा. वी हैव OH ऑल्सो एट ऑर्थो पोजिशन. OH का क्या होता है? प्लस m और माइनस m. प्लस m भाई यार क्या हम
Plus
बोले
M
यार.
because it's connected to a electropositive electron.
Less M.
यार तो ठीक है बट टेक सम टाइम. हम तो बोलेंगे टेक, डोंट टेक एनी टाइम, लुक एट द नोट्स एंड टेल मी. ठीक है ना. व्हाट अबाउट NO2 इन द ऑर्थो पोजीशन? NO2 is also in the ortho position. Minus M.
Minus M.
What about OH? But OH is now at the meta position. So please here you have to understand कि meta position में plus M increases the at ortho and para only. It has no effect on the meta position. तो अगर meta position में कुछ है, that means it is not going to have any effect. ठीक है. So it will neither be plus M or minus M. Whenever something is at meta position, you will not look at the mesomeric effect. You will rather look at the inductive effect. And since oxygen atom is more electronegative, it will be pulling electrons through inductive effect. So यहाँ पे ये माइनस आई का इफेक्ट शो करेगा. बात समझ में आ रही है? yes or no, please tell me guys.
Yes, sir.
Make sense? अब ध्यान से देखिए जरा. अब प्लस एम क्या करता है? इट इंक्रीजेस इलेक्ट्रॉन डेंसिटी या डिक्रीजेस इलेक्ट्रॉन डेंसिटी? रीड एंड टेल मी.
Increases.
I've just written it. Plus M increases electron density. It increases the electron density. Minus M will decrease the electron density. And this is also going to decrease the electron density. Now, if something is increasing the electron density, it will be more stable. है ना? Because carbon free radical is electron deficient. Electron deficient चीज को इलेक्ट्रॉन दीजिएगा. If it is electron deficient, उसको इलेक्ट्रॉन की जरूरत है. आप उसको इलेक्ट्रॉन दीजिएगा तो stability will increase. And here the stability will decrease. And here also the stability will decrease. Now, if you see where the stability will decrease more, then in that case, we can say in the minus M effect, it will decrease more because here in minus M, there is complete shifting of electron. And in inductive effect, there is partial shifting of electron. There is just displacement of electrons. That is what would happen. The stability would decrease more in the C case. Here, there will be no effect. Neutral या फिर zero कर दिया हमने. What is the most stable here? The most stable is B. न्यूट्रल एंड जीरो आएगा उसके बाद बिकॉज इट इज नेगेटिव हो जा रहा है यहाँ पे, माइनस हो जा रहा है यहाँ पे, है ना. स्टेबिलिटी इज डिक्रीजिंग. हियर नथिंग इज हैपनिंग टू द स्टेबिलिटी. सो बी एंड देन ए. एंड इफ आई लुक बिटवीन सी एंड डी, then D and the least stable will be C. Does this make sense? Yes or no? Please tell me, guys. Amna, Rishita, आपके Khadija, Khudeja, Humayda, Rishita.
Yes,
Please write this down. Write this down. Raise your hand once you're done writing. Write quickly, guys. Waiting for Khadija, Khudeja, Umaid. Just waiting for Umaid. Akib, you're done, right?
Yes, sir.
Okay.
Done, sir.
Now write order of plus m. So the different plus m group, some plus m group, they are going to have a high level of increase in electron density in the benzene ring. है ना, वो बहुत ज़्यादा electron density दे सकते हैं compared to the others. So that would depend. First of all, CH2 negative. Carbon, it is a electropositive element. It is not an electronegative element. जिसकी electronegativity उतनी नहीं होती है, and it is having negative charge, so it can easily give the electrons. Followed by NH negative. Followed by O negative. All of these are having negative charge, but the difference is that oxygen is more electronegative, so it will give the electrons a bit reluctantly. It will be resistant to giving the electrons, then nitrogen, and then carbon. Then comes the neutral. In neutrals, we'll obviously be having NH2 with a lone pair. Then we can have NHR, and then we can have NR2. And after that, we will have OH with two lone pairs, but that two lone pairs is not going to make any difference on the order. It's the electronegativity of oxygen which is going to make the factor which gets it lower than the nitrogen, even though it is having two lone pair electrons. Then OR. After that, we will be having NH, C double bond O, and then R. Now, here the lone pair is with nitrogen atom, but this lone pair can go this way also for the resonance rather than going towards the benzene ring, right? That is why it is lesser than oxygen also, even though nitrogen is less electronegative than oxygen. Iske baad, we will have the same equivalent structure of oxygen, C double bond O, and then followed by R. Here we are having two lone pair electrons. So here also it is lower than the previous cases because this electron pair can go into resonance in this particular direction also. Okay. So this is the order of plus m. Now write the order of minus m. Is someone speaking? Khatija?
No, sir.
Okay. Order of minus m. So obviously the positive charged atoms will be having the highest minus m strength. Then if I talk about the neutrals, NO2 is largest, followed by C triple bond N, followed by carboxylic acid, followed by the ketone, and then aldehyde. Copy this down, raise your hand once you're done. Waiting for Amna, Khadija, Khadija, and Rishita. Everyone is done? Okay. Write the next. Achha. So mesomeric effect is completed. The next electron displacement effect that we are having is hyperconjugation. So please write the heading. Hyperconjugation. So what is hyperconjugation? It is known as the delocalization. Please write this down. Delocalization of sigma, that is CH bond, electron with pi bond, or positive charge, or free radical is called hyperconjugation. Right, next. Hyperconjugation is AKA no bond resonance and pi sigma conjugation. Write this down. Raise your hand once you're done, and then I will explain what hyperconjugation actually is. Waiting for Amna and Khadija. See here, guys. First thing is that you need to have a carbon positive charge, या फिर free radical, या फिर pi bond, anything. It just need to have a p orbital that is parallel. Okay, like this. This type of p orbital should be present. And adjacent to this particular carbon atom, we need a CH3, a sp3 carbon atom. Now this sp3 carbon atom, so CH3 zaruri nahi hai. This carbon can have anything else, but it should have at least one hydrogen atom. Okay, can have anything else, but it should have at least one hydrogen atom. Now let us look at the bonding that's there in the carbon hydrogen bond. So the carbon atom will be having a sp3 orbital, and the hydrogen will having the s orbital, and they will be bonded like this. Now, as you can see, there is electron density in this bond, and this carbon atom, it is having a positive charge, or at least you can say it is electron deficient because it is only having 3 bonds, right? Now, this electron density, the electron density which is wave in nature, it can, for a fraction of second, momentarily speaking, this electron density, whatever is present here, this can move to this particular bond, and obviously it is very much likely because it is having a positive charge, and positive charge would attract the electrons. So what we can say is that for a moment or for a fraction of second also, what can happen when this is going to move here, then you will see something like this. The carbon with two bonds, it will make a double bond with this carbon atom, and it will have the two carbon atom like this, and there will be a hydrogen positive here. There will be a hydrogen positive which is having no bond. अब ध्यान से देखिए, अगर both of these structures आपको लगे सर हाइड्रोजन ऐसे पॉजिटिव अलग कैसे हो गया, so I will say see, here also we are having a positive charge, ना? One species having positive charge in this particular system, and in this system also there is one hydrogen with positive charge. यहाँ पे भी आपके पास एक atom है जिसके पास क्या है, we are having a positive charge in that. So both of them is not very different. Both of these structures, electronically speaking, if I speak in terms of energy, then I can say that both of these structures are not very energetically different. Here also we are having carbon with a positive charge, and here we are having hydrogen with a positive charge. So this type of bond shifting, that is from sigma bond to converting it to pi bond, sigma electron is getting converted to pi bond. This is known as hyperconjugation. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
Correct? Okay. Now, this hydrogen can further add on to this carbon or that carbon. That is another thing. But I hope all of you understood that what is the basis of hyperconjugation and how it occurs. Okay. Now, obviously, there are two conditions which is required for hyperconjugation. You guys can see the screen. Yeah. So please write conditions for hyperconjugation. First, at least one sp2 carbon. At least there should be one sp2 carbon. What is sp2 carbon? The sp2 carbon atom can be carbocation, free radical, or a carbon with double bond. है ना? इन्हीं cases में you are going to look at a sp2 carbon atom. इन्हीं cases में we will have sp2 carbon. ठीक है? ध्यान से. Second is carbon adjacent to sp2 carbon, that is alpha carbon, should have at least one hydrogen. At least one hydrogen. Write this down. Waiting for Amna, Khadija, and Khudeja. Just waiting for Khadija now. See here. We're going to look at some examples. If you see CH3 positive, then you can see that this is the sp2 carbon atom. Please don't write anything right now. This is the sp2 carbon, and there is no alpha carbon, therefore zero alpha hydrogen. We don't have any alpha hydrogens here, right? Let us look at another case where you are having CH3, which is bonded to CH2 with a positive charge. We can see that this is the sp2 carbon, and this is the alpha carbon. Right? This is the alpha carbon, right? This is the alpha carbon, and this alpha carbon is having how many alpha hydrogens? This carbon has 3 hydrogens. It is 3 alpha. If I take another case in which we are having a 2 degree, in which we are having a 2 degree carbocation, CH3 bonded to carbon with 1 hydrogen and another CH3. This middle carbon is having a positive charge, right? Now, this is having sp2 carbon, and both of these are what? Alpha carbons. If I count now the alpha hydrogen, this is equal to 6. Can you guys see that? Yes or no? Please tell me.
Yes, sir.
Right? Similarly, if I take the 3 degree carbon, CH carbon, and 2 more CH3s with a positive charge here.
So there'll be 3 alpha carbons.
Yeah, correct. So this is sp2 carbon. So the adjacent to sp2 is this carbon, adjacent to sp2 is this and this carbon. So here we're having how many? 3 alpha carbon. 3 alpha carbon. And if I count alpha hydrogen, it will be equal to 9. And if I look here, this is 1 degree, this is 2 degree, and this is 3 degree. So the 3 degree carbocation, it has 9 hydrogen with which it can make a double bond, right? So jitna zyada alpha hydrogen hoga, more the number of electrons it would be getting, more the number of pi bonds it can make, and that is why the most stable is the 3 degree, and then the 2 degree, and then the 1 degree. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
ठीक है?
Yes.
Similarly, देखिए ये सेम चीजें होंगी बिल्कुल आपके पास फॉर दी rather than free radical, if we are having, sorry, rather than carbocation, if we are having a free radical. The free radical is also sp2. The same will be the order of stability. Please write this down. Raise your hand once you're done. Waiting for Khadija, Humayun, and Rishita. right here. Determine the number of alpha hydrogen in following. Now, I hope you guys know this structure. No? Please do this. We'll give you guys 3 minutes for this. Once you're done, you'll send the answers on my WhatsApp. Yes, 3 minutes are over. Please send me whatever you have done. Please send. Acha, somebody has sent. रिश्ता आपने ना थोड़ी हड़बड़ी कर दी है. काउंट कीजिए नंबर ऑफ हाइड्रोजन एंड देन ये
Sir,
सामना is sorry
in which one?
the second and the third one. आपने वहां पे काउंट नहीं किया ना हाइड्रोजन्स. Just saw that there are 2 carbons, तो वहां पे आपने 6 लिख दिया. आके बाकी कीजिए फिर. इतना कम नहीं चलेगा. Do the rest of them.
Yes, sir. Do.
Sir, first one is correct.
हाँ, first one is correct. Yes, सामने first one is correct. Rishita, you got where it is wrong? Yes or no? What are you saying?
Yes, sir.
Yes, that is correct. You understood ना the mistake, right, Rishita?
Yes, sir.
ठीक है. फिर अगला वाला भी देखिए. Send Ace. Rishita, बाकी भेजिए. आमना, what about you? You also stopped sending the answers. बस एक किया आपने. अगला कीजिए.
Doing so.
हाँ, it should not take much time ना. You have to just need identify कि sp2 कार्बन कौन सा है. उसके बाद you need to identify what are the alpha hydrogens adjacent कार्बन वाले होंगे. Akib, you have also not sent the answer.
I'm trying, sir.
Third one. Yeah, correct. See here, guys. It's not very tough. This is the sp2 carbon. Adjacent to directly bonded to sp2 carbon, we have 2 carbons. This is 1 carbon here and 1 carbon here. This carbon atom is also having 2 hydrogens because each carbon will have 4 bonds. So the number of alpha hydrogen here, it is equal to 4. If I look at the next case, then this carbon atom, this is sp2, and there are 3 carbon atoms which are alpha carbon adjacent to the sp2 carbon. Now, all of these 2 are having 2 hydrogens each. And this is actually CH3, right? I hope you guys remember how to identify the number of hydrogen atoms. So here, if you count the number of alpha hydrogen, it will be equal to 4 plus 3, that is equal to 7. This is the first case. It is similar to the one that same as the one we did in the example. This is sp2. This is CH3 and CH3. And that is why the number of alpha hydrogen, it is equal to 6. Right, next. Stability of carbocation free radical and alkenes is given by hyperconjugation. More the number of alpha hydrogen, higher is the stability. Higher is the stability. So if I look at alkenes, carbon free radical and carbocation we have already seen. If I look at alkenes, then you can start with a simple alkene, that is carbon and hydrogens like this. This is CH2, CH2. Now here if you see, this is sp2 carbon atom. This is sp2 carbon atom and there is no alpha carbon, therefore there will be no hyperconjugation. है ना? यहाँ पे hyperconjugation नहीं हो पाएगा. There will be no hyperconjugation here. And if you're going to see that, for example, if you have something like this, C double bond O, sorry, C double bond C, and you have one CS3 group somewhere here, and the others are hydrogen, then in this case, we can see that this is sp2, this is also sp2, both the double bonded carbon atoms, and there is one alpha carbon. So alpha carbon is equal to 1 and alpha hydrogen, it is equal to 3. Now, if you have two of CS3s, for example, CS3, single bond CH, double bond CH, single bond CH3. Now, both these carbon atoms are the alpha carbon. And the number of alpha hydrogen that we are having, this will be equal to 6. Understood? Now, if you have more, we can have even more. No? We have carbon atom and CH3 whole twice, doubly bonded to CH and then CH3. Now, in this case, we can see that these two CH3s, these two CH3 and this CH3, both of all of these three are alpha carbon. And number of alpha carbon, it is equal to how much? 3. And number of alpha hydrogen, if you count, it is equal to 9. You can have even more if you have CH3 carbon, doubly bonded to carbon, CH3 whole twice. Now, in this case, we can say that the alpha carbon, it is equal to how much? 4. And the alpha hydrogen, it is equal to 4 3s are 12. Now, the most number of alpha hydrogen is in the last case, and that is the most stable alkene. You write this down, raise your hand once you're done.
Sir, can you scroll up?
Up? How much? This
Can
much?
you-
Where, Amna?
And that points one stability of
Those points, no? ठीक है. Write this down. Raise your hand once you're done. Waiting for Khadija and Khudeja. Okay. So I hope, like, let us suppose we are having this is A, this is B, this is C, and this is D, and this is E. Okay. So if I talk about stability, then A is the least stable, followed by B, followed by C, followed by D, and then followed by E. Okay. This is all due to the hyperconjugation. All of you got this, guys? Yes or no? Please tell me.
Yes, sir.
Now, next, stability of reactive intermediates. अच्छा, wait. Note एक second. There is just one point that we need to write. See here, guys. See here. देखिए यहाँ पे भी आपके पास कार्बन विथ 3 हाइड्रोजन्स है. Okay. Now, as you can see, this is the sp2 carbon. This is the alpha carbon. Alpha carbon is having a hydrogen atom, right? It is having a hydrogen atom. Now, what happens here is that according to hyperconjugation, this can break a bond. Right? This carbon hydrogen bond can break. And when the carbon hydrogen bond breaks, carbon is more electronegative than hydrogen. So carbon gets the electron. These two hydrogens are as it is. It gets the electron negative and H positive. And as you can see, double bond like this. Now this negative charge moves here, and then this can move here. Now, as you can see that this carbon atom, which is a key atom, which is having a negative charge or a lone pair electron. I mean, wherever there is a negative charge, there is a lone pair. And you can see that there is a electron push towards the benzene ring. Therefore, we can say that CH3 attached to benzene ring acts as plus M group via hyperconjugation. Got this? Yes or no? Please tell me.
Yes, sir.
Write this down. Raise your hand once you're done. Waiting for Khadija, Humaid. Khadija, and Humaid. इसके बाद लिखिएगा स्टेबिलिटी ऑफ रिएक्टिव इंटरमीडिएट्स। Now write this in a separate page, और इस मतलब या तो अभी मत लिखिए, लेकिन once you are done writing this in your copy, take a separate A4 size page and write this once again and paste it in your wall or your desk, जहां पे भी आप पढ़ते हैं ना उसके नजदीक आप इसको पेस्ट कर लीजिएगा, because this is something that is going to help you a lot in the 12th standard. ठीक है? So whatever I'm going to write here, whatever we are going to understand here, please try to remember these points in the 12th standard. It will make the organic chemistry very easy for you guys. And the first thing, that is carbocation. The reactive intermediate you have 3 ना, तो उसकी carbocation की stability is the most important. आप कुछ मत याद कीजिए, बस carbocation की stability याद कर लीजिएगा, then it will be very helpful for you guys in the next year. Carbocation. Now, can somebody tell me carbocation? It has, what is the hybridization or what is the charge on carbocation? Tell me, guys.
Positive.
Positive charge. So carbocation, it has positive charge and it has 3 bonds also. Now, please see. Carbocation is electron poor and with positive charge. Therefore, electron donating groups, if we attach a group which gives electron, it would give electron to carbocation, it will stabilize the carbocation. Therefore, electron donating group stabilizes the carbocation. That is plus M, plus I and hyperconjugation. Hyperconjugation में भी क्या होता है? इलेक्ट्रॉन मिलते हैं ना, it gets electron, and electron withdrawing groups destabilizes the carbocation, that is minus M and minus I. These groups are going to destabilize the carbocation. Okay. Another point, when we are looking at plus M, in plus M, more the number of resonating structure, higher is the stability. ठीक है? In hyperconjugation, more the number of alpha hydrogen, higher is the stability. Okay. Now, also remember, please, let us suppose groups in which you are having plus M effect. In some, you're having hyperconjugation, and some you're having plus I. So please remember that mesomeric effect has the highest, and then hyperconjugation, and then inductive effect. है ना? इसको please ध्यान रखिएगा हमेशा that mesomeric effect is the greatest, it has the largest influence on the carbocation or any other reactive intermediate? Write this down, raise your hand once you're done. Waiting for Khadija, Mad, and Rishita. Second one. You're having carbon free radical. Carbon free radical, it is also electron poor. You know, it is also electron poor. It does not have a positive charge, but its octet is incomplete. With in octet. And factors affecting stability is same as that of carbocation. Factors are same as carbocation, exactly same. No difference. The next one is carbon ion. So the carbon ion, we know that it has 8 electron with negative charge. With negative charge. So if I talk about the stability, it is having negative charge, therefore electron donating group decreases stability, will decrease stability, and electron withdrawing groups, the groups which are going to withdraw the electrons, that means take up the negative charge, will increase the stability. It is directly proportional to minus m, inversely proportional to plus m, directly proportional to minus I, inversely proportional to plus I. Please write this down. Raise your hand once you're done. Waiting for Khadija, and Rishita. Okay, most of the students are done. Arrange the following according to stability. Yeah. So let us suppose you have CH3, CH2 negative, and then you have CH2 doubly bonded to CH negative, and then you have CH triply bonded to carbon negative. Okay. Now, if you see that all these three species are carbon ion with a negative charge. The only difference is that they are bonded to CH3, CH2, and CH, a double bond, single bond, double bond, and triple bond, respectively. But the difference here is not the carbon atom, rather the hybridization of carbon. This is sp3 hybridized carbon. This is sp2, and this is sp. Now, as you can see, in sp3 carbon, this is less electronegative, sp2 is more electronegative, and sp is the highest electronegative carbon atom because it is having more percentage s character. This is very highly percentage s character is present in the sp carbon atom. 50% s character is present, and the s orbital is very near to the nucleus. That is why the nucleus can pull the electron very easily from the if the hybridization is sp. That is why this sp carbon is able to pull most electron, and hence we can say this is most stable, and followed by these two. Please write this down. Raise your hand once you're done. Waiting for Amna and Khadija. Okay.